So this is the configuration dashboard for the lossy compression algorithm running on the Oustaville platform, or soon to be. As you can see, it's a web application, and to access it, you need an HVL provided Microsoft account. Once you access the platform, you are presented with first of all, the top menu here where you will select your site to be configured, the hub on the site, etc. Then you have fields showing you the current configuration values on the left. You have fields showing you the targeted values on the right. So these are the values that you might want to configure and will simulate for to ultimately decide if you want to configure, if you want these values configured on the platform. And then below we have representations that you will see in a little bit that show you visual graphs of energy consumption, compression, as well as tabular representations of the same. So let's go ahead and show a really quick example of how one would configure a lossy compression algorithm on the Oustaville research site. So I pick my site, I pick the hub that I'm interested in, and I choose, for example, the temperature sensor on that hub, and out of the properties covered by the temperature sensor, let's say I want temperature. So right away, the platform is going to load any current values that might be configured for this sensor, meaning if there's an existing configuration, you're going to see it here on the left. Currently, there's no existing configuration for the temperature sensor, so what we're seeing is that there's only ever one data point buffered on the sensor at a time, and there is no inaccuracy in the data because the data is not being compressed. So let's say we are aiming to compress the data and save a little bit of energy in our underwater acoustic network. So I say, okay, I'm willing to buffer 10 points on the device, and to explore a little bit of variance, I say ±3. Beneath the fields that I just populated, we also get an immediate calculation of how long it's going to take to buffer 10 data points. So given that we have a 30-minute interval, this is how long it's going to take to buffer. This is how long we're going to have to wait ultimately for the 10 data points, which means this is also going to be the age of information of the first data point in this series. After this, I put in my desired inaccuracy, so I'm willing to tolerate, for example, 7% with a variance of maybe 0.5. Okay, so immediately you'll see that I get a calculated compression ratio. So compression ratios above 1 mean that we are actually compressing with respect to uncompressed or raw data. Compression ratios below 1 mean that we're not compressing data. So we're actually saving a little bit of data here, as we can see. So maybe I'm willing to buffer a little bit more. So let's say like 13 points, okay? And if I increase the variance in my epsilon, okay, then I get a little bit more. So I get a little bit of a higher compression ratio. Below these fields, we have two buttons. We have a run simulation button that's going to explore the combination of these values with the ranges that we've given, because we might not be sure that the combination we desire really is 13 points and 7%. It might be a little bit higher or a little bit lower for each one of these. So this is where the simulation comes in handy. Once we've decided on a combination of parameters, we can click on Apply Configuration, which will then apply this configuration onto that sensor on the platform. So then we're going to see it under current values. So let's go ahead and run the simulation for these parameters, and then when we do that, we get immediate graphical representations for a few things. Here we're seeing the energy consumption for this value of inaccuracy that we've chosen and this value of data age, meaning this is how much energy consumption we're going to be using in terms of watt hours per day. We can also look at a 3D representation of the compression curve. So the compression ratio is a function of epsilon and batch size. We can see here how it reflects on the parameters that we've chosen. And if we look at this, the irregularities in the curve, we can actually notice that it is a little bit more worth it to go from, for example, 14 points to 15 points versus something like 13 points to 14 points. So we can see how the gradient in the curve changes by changing the batch size. And this tells us that maybe increasing the point by 1, if we're on the fence here at 14, is going to give us quite a few benefits, whereas increasing the point by 1 if we're at 13 isn't really going to change all that much for us. If we prefer, we also have a tabular representation, so of both the energy calculations and the compression calculations. So this gives you the same thing, but it's just a different form. And ultimately, we also have a combined table showing us everything, so compression ratio and energy consumption in one for the range that we've selected here. And as you can see, it's paginated, so we can explore really fine combinations of our epsilon and batch size if we so desire. And let's say that we chose this combination in the end. We're happy with this compression rate. I'm going to click on Apply Configuration. And now this configuration has been applied to the current values, and as you can see, it comes over to the current values. And we can simulate other combinations also in the meantime if we want to. So for example, this changes a little bit. Yeah, run simulation for a new one. Let's say that we might want a different kind of combination, and we decide that, yeah, I'm happier with 14 and 6. Apply that one, and we can see it applied. So here we see currently how many points we're buffering, how long it's going to take to wait for the oldest point, what the inaccuracy in our data is going to be, and this is how much we are actually compressing in terms of raw data or uncompressed data.